Hello, I am going to show you how to do the present value of a bond Excel project. And this recording is going to go pretty quickly, but I'm assuming you will pause and rewind or whatever. I'm actually just going to do through the project, kind of crash through it and just complete it. So let's start with the instructions. So what you're going to do is take the present value of the bond using 4 different methods. The first two use time value of money factors, and these last two over here, they're going to use the present value function in Excel. And then the last thing you do is test to make sure that all 4 ways are calculating the same present value. The time value of money factors will have some error because of rounding, but that's okay. It'll be a couple bucks. That would be fine. But if they're way off, then you have to go back and fix it. Okay, so the first tab is the present value factors tab. And we go to step 1. It says choose a market interest rate between 6 and 8% that does not end in 0, for example, 6.3. So I'm going to leave it at 8% because you're not supposed to do a 0.0. So I'm going to do this one as an example. Just don't choose mine, all right? Okay, so the first thing it says is do this. Then the second thing is to fill the interest payment. I've calculated it for you. You just have to point to it using the equal operator. Now you could point to that cell 5 more times. I find it easier just to point to the one interest payment. Woo! And then let's see if I can drag it down, and that's okay. Yes, that works fine. Sometimes I use Control C and then paste with Control V, Control C copy. These are all zeros. That's what the dash is, the accounting format. If you're going to go into accounting, use the dash, the accounting format. And the third step, excuse me, is point to the principal. Don't type it in. We want to use Excel to point to it so we don't have to retype. Now, what this function does is it's going to create the present value for each individual cash flow. Tells you what each individual cash flow is worth, and we total up the present values. The factors here I've created using a present value function, and I'm going to leave that in there so you don't have to type it in every time you change the interest rate. Plus, your factor table doesn't have it. So if you did 6.3, see how they change automatically? And I'm the nicest professor ever, so I put this in here. So it's surrounded by the round function, which rounds it to 5 decimal place. So it tells you the number of digits. The number is the present value for that cash flow, which uses 4% since there's 2 payments a year. The number of periods for this payment, it only has to be discounted 1 year, or 1 period, which is 6 months, because the 5,000 is paid in 6 months. So payment, each of these things, by the way, is called an argument. It's just a definition for the function, the PV or present value function. Payment, what Excel means by that, the PV function means it's an annual payment or periodic payment. That's an annuity payment. So because we're doing lump sums, we just need this FV, which is the final value or the final payment. And so that's what the 5,000 is in this case. And I set it to $1 because if I put $1 in there, it will give me the factor essentially, because that's what you would multiply times $1. We have $5,000. We're going to multiply 5,000, and I'm going to put a minus here. I'll explain later. Minus 5,000 times the factor. Okay. So that looks okay, but this looks a little light over here. So what's happened is we have to take the factor also again times 100,000. Oh, it should have been a minus. Minus, a minus. I don't know what's happening with that, but I don't care because I'm going to do it the other way, which is we have one cash flow of 105,000. So we could say equals a minus 79,031 times the quantity of 5,000 plus 100,000. Let's see. Okay, 105,242. And I know that's right because I know. All right. So you'll get your first answer. And then you'll go on. Let's do it the second way with factors. And this is how we normally do it. When the interest payments over here, this is an annuity. And specifically, it's an ordinary annuity. Here's time 0. The first payment doesn't happen until 1 period after the present value date of 0. So that's ordinary. So I've created this factor in a similar manner, and but it's an annuity factor. Oops. Equal the payments equal the face value. This is an annuity factor. So the difference is I put in the interest rate, and these dollars mean it's just a fixed reference. When I copy paste this formula, it will always point to G9. And the number of periods is payments per year times the length of term in years. So this will be 6, G5 times G7. So I put the dollar in the payment column. So it's going to give me a factor for an ordinary annuity. And then I copy pasted this formula down to here, and all I did was switch the payment to 0 and the FV to 1 to get the lump sum. Okay, equal minus the payment times the factor. And I'm going to Control C, Control V, and equals the sum of these two. And I think that's the same thing. So I'm moving on. Don't touch any of these. The only one you're going to touch is this highlighted one, and it affects all of them. All right. So I did the 2-factor ones. I'm going to break here and come back to this present value of Excel function one. We've gotten through the instructions, the present value of each lump sum individually, and the present value using an annuity factor plus the lump sum. So that's all the factors. I just like to keep these videos short, so I'm going to break now and see you on part 2 with the Excel function.